Okay, we talked about this just a little bit before break, but what we are looking at is the product rule for exponents and then addition of like terms when there are exponents involved. So first of all, the product rule for exponents can come from a definition that we have. We know right now that 3 to the 5th means the same thing as base 3 used as a factor 5 times. So it means 3 times 3 times 3 times 3 times 3. So we want that factor 5 times. So if I ask you to take 3 to the second, 3 to the second is the same thing as 3 times 3. And if we are going to multiply that times 3 to the third, that means I got to multiply it by 3 as a base 3 times. Then that looks, this right here, 3 times 3 times 3 times 3 times 3 looks the same thing as 3 to the 5th. So this answer right here is the same thing as 3 to the 5th power. So what does that mean? That means that if you are multiplying like bases, where keep in mind the base is that value of 3, what you do is you add those exponents together. So if I ask you to take 3, which is right here, just that one factor, and I take it times 3 to the 4th, that 3 to the 4th means you're going to use 3 as a factor 4 times. Whoops. Then your overall answer is 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5. That is the same thing as 3 to the 5th power. So basically what the product rule for exponents says, if you're going to take x to the a power times x to the d power times x to the d power, what you do is your final answer is going to be x to the a plus d power. You add the exponents when you multiply like bases together. So if we apply that to these variables, x to the 5th times x to the 7th times x to the 2nd, what you do is you add the exponents. Since the base is the same, you add those exponents. So 5 plus 7 is 12 plus 2 is 14. So you end up with x to the 14th power. And you could just sit there in your head and go 5 plus 7 plus 2. You don't have to write this step down, but keep in mind you add those exponents together. It doesn't matter if the base is a variable such as x or if it's a number such as 5. My base is 5, the exponent is 2, the base is 5, your exponent is 3, the base is 5, the exponent is 2. So you're going to have your base to the sum of those exponents. And if you add those exponents together, 2 plus 3 is 5, plus 2 is 7, you end up with 5 to the 7th power. In the next example, now we're back to variables. You have p to the 5 times p to the 12th. If you add the exponents together, 5 plus 12, and 5 plus 12 is 17. So it simplifies into p to the 17th power. And finally, the last example deals with base 4. Each one has a base of 4. So we're going to add those exponents. 2 plus 3 is 5, plus 25 is 30. So it simplifies into 4 to the 30th power. They just want it simplified in exponential notation, which is that base raised to that power. Because I'm pretty sure on this one, you don't want to take 4 times 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 4 and do that 30 times. So as I mentioned before, up here, when I said if you take x to the a times x to the d times x to the d, that's equal to x to the a plus d plus d. I tried to throw that little trick in so you can see that maybe you can make that connection that it was add those exponents together. In general, they say it this way, or your textbook defines the product rule for exponents as if you take x to the m times x to the n, where x does not equal 0, then your answer is x to the m plus n power. So just remember that you add the exponents. So let's look at some more examples. Okay, so we can use this to help us simplify expressions. Remember, an expression doesn't have an equal sign to it. So we can use this to help us simplify expressions that contain exponents. So if I'm asked to simplify x squared, y squared, x to the fifth, y to the third. Now keep in mind those are all being multiplied together. If I am asked to simplify that, you only add the exponents of like bases. So all I can work with is I find that x to the second and the x to the fifth. Those are like bases. So when I simplify, it's going to be x, and then I add those exponents. But then what we also have to do is take the y then as a separate value. And if we look at the y separately, we're going to add those exponents as well. So it's going to be y raised to the 2 plus 3 power. So your overall answer would be x to the 2 plus 5 means 7, and y to the 2 plus 3, which is 5th power. So it's x to the 7th and y to the 5th. That's the simplified version. Each variable should only occur once in your solution and not any more than that. So let's look at another example. Okay, so example 2, if I ask you to simplify x squared times y cubed times m to the 5th times x cubed times y squared. As we go through and look at it, you add the exponent of like bases. So I want to find all of the x's, which is x squared and x cubed. Those I'm going to be able to combine. If I add those exponents together, you end up with x to the 2 plus 3 is 5th power. Now continue your answer. We have another variable, which is y. That's going to be y cubed and y squared. If I add those exponents together, 3 plus 2 is 5. So it becomes y to the 5th power as well. And then we still have this m left. There is no other factor of m. So it's just m to the 5th. And in your answer, don't forget we got to add that m to the 5th as a factor. So your answer becomes x to the 5th, y to the 5th, m to the 5th. So the next thing we want to talk about is a definition that deals with exponents. We need to define the notation of x to the first power. X to the first power means the same thing as just x. So for an example, if I talk about 5 to the first power, well, that means you use 5 as a factor one time. It's just 5, so that's equal to 5. If there is no exponent there, it's understood to be a 1. So if we look at another example here, example 3, where I simplify x times y squared times x cubed, I want to add the exponents of the like bases. So once again, we look for the x. We want to group the same variables together. You look for the y's, and you add the exponents. So what we have to remember is go back to this definition right here. If it is just x, that means the same thing as x to the first. So this is understood to be 1s right here. So if we add the exponents together, 1 plus 3 makes this x to the 4th power, and 1 plus 2 makes your other factor y to the 3rd power. So your simplified answer is x to the 4th, y to the 3rd power. Let's look at another example. So if we look at example 4, we are multiplying. Every single one of these variables is being multiplied together. So we want to find all of the m's. We're going to add those exponents together. You find the next variable is p. So I look at all of those exponents. And then the last variable we have is x. So we're going to look at those exponents. Once again, as you go through this problem, if I look at the m's, I have a 3 plus, there is no number there. If there is no exponent, it's the same thing as 1. So as I add the m exponents together, you have 3 plus 1 is 4, plus 2 is 6. So it's m to the 6th. If you look at p, this, once again, there's no exponent here, so it's understood to be a 1. So 1 plus 5 is 6. And if you look at the exponents, no exponent is understood to be a 1. 1 plus 3 is 4. So your answer is m to the 6th, p to the 6th, x to the 4th power. Okay, I only have about 4 minutes left in my recording, so I'm going to try to make this quick. We notice that 3x squared plus 2x squared, those are like terms because you have the same variables raised to the same power. So you just add the coefficients together. So the only thing we want to add together are these coefficients of 3 and 2. So 3 plus 2 is 5. And then you keep the variable and the powers the same, so it ends up as 5x squared. Do not make it 5x to the 4th. We are not multiplying like bases like we are in the previous examples. All we are doing is adding like terms. Now remember, x squared y p to the 5th and p to the 5th x squared y are like terms because each variable is raised to that same power. X is being squared. Y is to the 1st power, and P is to the 5th power. The commutative property of multiplication says it doesn't matter what order those show up in. So the next examples, I'm going to give you 3 real quick, and it's going to work with adding like terms. So if we look at example 5, it says simplify, and I have this following expression right here. We want to simplify by adding like terms. I should have put that in there, by adding like terms. So the first term, remember, the coefficient's understood to be a 1, but as I look at it, you have x squared. Well, the second term is not a like term because it's x to the 1st. Same variable, but not the same power. In this third term, we have x squared. That could possibly be a like term, but I need to make sure the next variables are the same. And the last one is not a like term because it's x squared. So to continue to see if it's a like term, all variables have to be raised to the same power. We have y to the 1st, y to the 1st. So far it's looking like the 1st and the 3rd term will be like terms. Then you have p to the 5th and p to the 5th. So the 1st and the 3rd term are like terms. So you have 1 plus 3. So if I add 1 plus 3, you end up with 4. Keep the variables the same. X squared, y, p to the 5th. That's how many of them I have. Now, if I look at the last 2 terms that are there, the 2nd and the 4th term, you have x to the 1st, you have y squared in both of them, and you have p to the 5th. The order does not matter. The variables are the same, so all I have to do is I have to add those coefficients together. Make sure you take the sign with it. So it is 2 minus 7, which is negative 5. And then your variables are x, y squared, and p to the 5th. Don't put a plus sign just because the next sign after that first yellow term is a positive. Add those coefficients together, and a positive or negative, add and subtract, is dependent on what you get when you add those 2 integers together. So we'll look at one more example. So if I look at this last example, simplify by adding like terms. Like terms, same variable raised to the same power. So in the first term, I have an m cubed. The second term, there is m cubed. Third term is m cubed, and fourth term is m cubed. So far, it looks like they all might be like terms. If I look at the next variable, x to the 1st. X to the 1st, remember if there's no exponent there, it's understood to be 1. X to the 1st. Oh, x squared. This is different. Because this is an x squared and all of the others are x's, even though there's that m cubed, that means that this term is going to be a different term. Now if I look at these 3 that I have y squared, y squared, y squared, p to the 1st, p or p to the 1st. So the first 3 terms, each one of the variables has an m cubed, each one has each term has an x to the 1st, a y squared, and each term has a p. So therefore, all I am going to